In this video, we're going to go through Learning Target 5.2.2, which is talking about similarity shortcuts. And so basically on Monday we learned like the long definition of similarity, where all angles must be congruent and all sides must be proportional. And so in that case, you have to do a lot of work to prove that all of those things are true. So mathematicians came up with similarity shortcuts, basically a smaller amount of information that you would need to prove, and then the rest will basically be true. So as long as this smaller information is true, then you can assume that all of the other information is true. And so we're going to learn about 3 shortcuts today that you can take to prove that polygons are similar. The first one is the angle-angle shortcut. And so the angle-angle shortcut means that we have 2 sets of congruent angles, then the triangles are similar. And we kind of talked about this on Monday as well, because if we know that 2 of the angles in a triangle are congruent, then we know that the third one has to be automatically, because triangles' angles add up to 180 degrees. But let's say we have, I'm going to draw like a quick picture for each shortcut, and then I'll show you what the problem will look like on an assessment. So we have, let's say, this triangle, and I know this is the right angle. And then we have this triangle, also with a right angle. And so using the angle-angle shortcut, you basically just have to see that because angle A is congruent to angle E, and angle B is congruent to angle D, because they're both right, then we know that triangle ABC is similar, and then you have to make sure you're lining up the correct sides. So A is the one with one arc, so we have triangle E. B is the 90-degree angle, so D, and then F. And the reason is the angle-angle shortcut. So this is kind of the setup. If you can prove that 2 of the angles are congruent, then you know that the triangles are similar by the angle-angle shortcut. So I want to show you one more example of the angle-angle shortcut. Let's say we have a picture like this. It's a very commonly used setup in geometry, where it's kind of a triangle within a triangle. And we have A, E, D, B, and C. And we know that this is 42 degrees and this is 42 degrees. And so basically you can like break this up into 2 triangles if you would like. It's the smaller of the 2 and then the larger of the 2. But what you need to find is 2 angles that are congruent. And right now we know that angle E is the same as angle D, because they are both 42 degrees. But then, because this is like a triangle within a triangle, you can see that both of the top angles are angle A, correct? So they're the same exact angle, and so they are congruent to each other because they're exactly the same. They are the same angle. And so because we can show that angle E is congruent to angle D, and angle A is congruent to angle A, then we know that our triangles are similar. So triangle AEB, which is the smaller one, is similar to triangle ADC, which is the larger one, by the angle-angle shortcut. So if you can find two angles that are congruent, you know that they're similar by the angle-angle shortcut, by AA. So now we're going to do another shortcut. It is the side, side, side shortcut. And these are pretty aptly named because angle, angle, you look for two angles. Side, 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 you look for three sides. And so in this case, we're not looking for the sides to be the same. We're looking for three sets of corresponding sides to be proportional. And so this is where you're going to have to make your ratios. So we're going to divide to be the same ratio. So let's say we have this example where we have triangle ABC, and we're given the side lengths of these triangles, so 72, 48, and 84. And then we have another triangle over here, which is HGF. And we're also given these side lengths to be 12, 14, and 8. And so you have to find the corresponding sides, and you could, if they don't give you a similarity statement or they don't tell you like what they're related, sometimes they do, then you can look at like the smallest sides should be corresponding, then the medium sides, then the large. So our small sides are 8 and 48. They're our two smallest. So we can have 48 over 8, which gives me 6. Our medium sides are 12 and 72, so 72 over 12 is 6. And our large sides are 14 and 84, which also gives me 6. So because these are all equal, I know that my three sides, all three sides, are proportional. And so triangle ABC is similar, and then you kind of want to match up these things. So A to B was the medium side, and our medium side is over here at 12. So we're going to go triangle HG, and then we only have one letter left, so F. So kind of make sure you match up the correct sides. So we got one more to do. So this is side, side, side. You have to prove them proportional. We already did angle, angle. And now the next one, the last one, is kind of a combination of the two. So the last shortcut we're going to look at is side, angle, side. So side, angle, side shortcut. And this one is pretty specific because you need two sets of proportional sides and not just any angle. So you need two sets of proportional sides and congruent angles in between. So you need the angle in between the two sides that are proportional to be your angle. So if you find another angle that's not in there, that won't work. It has to be side, angle, side in that order. The angle has to be in between the two sides. So let's say we have a triangle like this with a right angle, and we have 36 up here, 15, and A, B, D. And then we have another triangle. This one also has a right angle. And then we have K, Y, X. So So now looking at this, I don't have all three sides, so I know I can't use the side, side, side. And I'm only given one angle, so I can't use angle, angle. And so side, angle, side is talking about a side, the angle in between, and then another side. And this one also has a side, an angle between, and another side. So it has to be like in that order all together. So we know that angle B is congruent to angle Y because they're both right angles. So we know that we have the angle congruence. Now we need to prove that the sides are ratios. So the smaller of the two are 15 and 10, which gives me 1.5. And the larger of the two is 36 over 24, which also gives me 1.5. So these are proportional as well. So I have my sides are proportional, my angle in between is congruent, so I know that triangle ABD is similar to triangle, and again, you got to match them up. So A to B was the smaller of the sides, and so we want to do X to Y. So X, Y, K. And so these are the three shortcuts. You're basically going to be asked to determine which shortcut can prove similarity. So you're going to be given a picture and some information, and then you're going to prove similarity using one of these methods.